Okay, hello everyone, and thanks for coming. My name is Yoni Friedman, and I'm the product manager for Amazon Translate, our fully managed, continuously trained neural machine translation service that we had just announced as generally available earlier this morning. So we'll start with Amazon Translate. We'll transition to Amazon Transcribe in about 30 minutes. So back to Translate, I would like to show you today how you can build multilingual applications with one API and just a few lines of code. So first, a bit of customer context. 55% of consumers buy only on websites in their own language. So if you're selling stuff, your reach is limited by the amount of languages that you support. And this is critical. In the state of California, for example, over 40% of families speak a language that is not English at home. This notion is, of course, true across the board. Customers want to communicate in their native language when they chat with customer service, email their coworkers, write posts and blogs, and so on. And that is really the majority of digital content that until today has not been translated in most cases. Which means that if you want to maximize your addressable market, you need to localize your assets, which includes translation, of course, but also adapting it to local dialects, your brand-specific style, language-specific morphology, and so on. The problem with that is that professional localization is a very, very manually intensive process with translators, project managers, QA folks, and so on. That means that you hire a localization firm that assigns at least a couple of professional translators per language pair that you need to get done, folks with master's degrees that often have very domain-specific expertise, who in most cases deliver a really high-quality result. But high-quality human work naturally takes time. So the minimal turnaround time for most projects is several days. And the average cost for that job is 15 cents per word, which is about $150 for your average news article. Multiply the amount of content that your business has by about 40 languages, which is, give or take, the amount of languages that can generate incremental revenue for your business, and you get a pretty hefty bill there. This makes professional localization an option that's viable only for your organization's most precious and valuable content. Think about your applications UI, your marketing content, any type of regulatory filings, and so on. Now, the opportunity becomes clear when you realize that over half, 51% of consumers actually prefer content in their own language, even if the language quality was not perfect. And the same applies to B2B. 51% of companies say that they'll buy software that supports other languages, even if the language is not perfect. Now, at Amazon, we've had the same problems over the years, and we've been using machine translation to solve them. We translate hundreds of billions of words every year, and that has been growing exponentially. So machine translation has been basically a key enabler to our international expansion. We use machine translation to translate product listings and reviews, search queries, website strings, functional content, communications with customer support, communications with vendors and sellers, product documentation, and a lot more. Now, until 2017, we ran these machine translation services on phrase-based, or also known as statistical machine translation engines, which basically enabled us to make a lot of content that we couldn't have otherwise available in many languages, but the quality was still quite limiting. We couldn't really use it for a lot of applications. And many of you have probably seen embarrassing machine translations, kind of like this one here, in the past. Then, over the last year, we had productized proprietary state-of-the-art neural machine translation engines. And that was a leap ahead for us in terms of quality, in terms of both current performance as well as the prospect of what we can do with it. Now, let me explain. In essence, statistical engines, which are the ones that we used to have, are basically a fancy lookup algorithm that makes decisions based on the probability of a certain word mapping in the source language, mapping to the word to a different word in the target language. The problem with these statistical models is that predominantly they don't understand context, and they're really limited to around, give or take, 5 words around the word that they're currently doing. But that's no longer the case with neural engines. I'm extremely oversimplifying this, but generally speaking, neural engines are built such that they mimic the way, they're inspired by the way that the human brain learns and processes information. And that means a ton in terms of performance. They understand quality, they understand context, they understand the focus of the sentence, and they understand morphology. Now let's take a look at an example. This is the Wenger Swiss Officer's Giant Knife on Amazon.de, personally one of my favorite products that I've ever seen on Amazon. Mind you, it has 87 tools, and it offers 141 functions, and that's guaranteed. So it's a pretty serious tool that we're looking at here. It also turns out that one of these tools is a toothpick. And here you can see what a customer in Germany wrote about their experience with it. Now here's how one well-known open source engine that still uses statistical engines would have translated this. Let me read that out loud to really leave an impression. Really very good pocket knife. Had yesterday after breakfast something poppy hang between the teeth. Because I once again found no toothpicks, I ordered mine without further ado this pocket knife. The integrated toothpick NUR 3 is very stable, and very quickly I could clean my teeth. Super. To the rest I can tell nothing, unfortunately, because I him not be emergency. So, the reader can kind of get the gist of the message here, but overall, not that great, and we wouldn't want to surface that translation. Now let's take a look at what our current neural engines do. Really a very good pocket knife. Had a little poppy between the teeth yesterday after breakfast. Since I didn't find a toothpick again, I ordered this pocket knife shortly. The integrated toothpick number 3 is very stable, and I could clean my teeth very quickly. Great. I can't say anything about the rest because I don't need it. Now, as you can see, we still have some work to do here, but this is much closer to the way that a human would have actually translated this phrase, this paragraph. And the meta point I want to make with this example here is that our engines have gone from producing results that kind of get the reader the gist of the original message to a point where they're much closer to proper human language, and are therefore tools that we can leverage for many more use cases. And this is evident if we quantify it too. So the dotted line that you're seeing there symbolizes our first experiments with neural architecture in July 2015. Everything before that was statistical engines. Now, as you can see, at first we saw a bit of a dip in translation quality because, frankly, there weren't many people that fully understood how neural networks worked at the time. But then we see that our performance really started to pick up the pace, and we really left the statistical engines far behind. Now, for context, we're looking at blue score. The y-axis there is the blue score. Without getting into too many details, this is the vastly most used metric for evaluating machine translation. Before neural, scientists were celebrating at annual conventions that we have about machine translation every half a point of progress per year. What we see here is 10 points in 2.5 years. And that is really, really symbolizes and shows how our scientists have made progress that is already improving in double digits the quality of translations, but also is showing an 8x improvement pace over what we had before. And these are two separate, very important points to remember. Now, one of the most important contributors to success with Amazon Translate, to your success with Amazon Translate, is understanding where to apply the solution. Because we're not implying by any means that the progress that we've made has made this perfect and there's never a mistake. This is still a machine learning algorithm. State-of-the-art machine translation is a great tool for any kind of content that flows in really large volume or is created and deprecated very quickly. So think about any kind of user content like reviews and posts, communication between customers and employees. Those are all great candidates if you think about any type of content that your users create. Other situations where companies need to sift through large volumes of content, for example, to extract insights are also a great fit. So if you need to extract sentiment from a large amount of multilingual content, classify lots of documents, or search through them, Amazon Translate lets you do that quickly, accurately, and very cost-effectively. And that is by far, like I mentioned, the vast majority of digital content that in most cases is still not translated and has a really large opportunity for our customers. Now, in other situations where the specific style of the content is critical, where you cannot allow for any mistake to be made in the translation, you can use machine translation to take a first pass at your content and then enable human translators, professional translators like I talked about at the beginning, complete the job by focusing on the accuracy and the specific style that your company requires. So again, think about your company's UI, marketing materials, regulatory filings, and so on. Now let's talk a little bit about what are some actual examples of customers that are already using this service. So Hotels.com is using Amazon Translate to translate customer property reviews before they run them through their own heuristics, their own algorithms that digest them and basically get the meaning, get the sentiment of every review. Isentia, which is a media monitoring service for brands, is using it to make content in languages that it couldn't analyze for its customers in the past accessible to its algorithms, which are built in English. And PubNub, which offers real-time communication platforms like Chat Engine, for example, is enabling customers to build multilingual chat applications using Amazon Translate. So if that's something that your business needs, you can use Chat Engine today with Amazon Translate. Next, I'd like to show a demo of translating real-time interpersonal communication. And in this application, Kashif, a solutions architect that works with the company Twitch, built an app that translates Twitch channels in real time. Let's take a look.
Hi, my name is Kashif Imran, and I'm a senior solutions architect at AWS. This is a brief walkthrough of the app showing real-time translation of Twitch chat. Here you see I'm on a Twitch channel where a streamer is playing game and live streaming it on the channel. You also see live chat on the right side of the screen. This is a German channel, so most of the communication happening here on the channel is obviously in German. I don't speak German, but this channel sounds interesting, and I'm curious to know about the conversation happening on this channel. Let's see how we can get this real-time chat translated and understand the conversation happening on this channel. Let me copy the name of the channel and switch to the app. I'll paste the name of the channel, select the source language. In this case, we'll choose German. Select the target language, which in this case I'll choose English, and click Go.
Connect to channel _SAN. You should now be getting live chat messages.
And voila, we are connected to the channel. We're getting the real-time messages on the left side of the screen, and the translation of those messages are on the right side of the screen. Let me go ahead and introduce myself to the channel. So if I type a message and hit send, you can see even though I typed the messages in English, it got translated in German. And if we switch back to the channel, you can see it's also posted in the channel in German. Now let's look at another channel with Twitch app and our translation app side by side. You see as messages are coming in the chat, they are instantly being translated and displayed in our translation app on the right side of the screen. Now let's talk briefly about how the application is built. Here you can see the architecture of our app is quite simple. Our app uses a Node.js library to connect to Twitch chat and start receiving real-time messages. As those messages come in, we use AWS SDK to call Amazon Translate, get the translated messages back, and display them in the UI. If user enabled the voice option, we then use AWS SDK to call Amazon Polly and get the synthesized speech back for those messages and then play them back to the user. Let's now dig a little bit deeper and look at the code to see how the application is built. Looking at the code, the app has two files, index.html and app.js. Index.html has all the necessary UI elements to get user input and show messages. App.js has less than 100 lines of code to get real-time messages from Twitch chat, get those messages translated, and then display on the UI. As you can see, we'll begin with some initialization code to wire up the UI. Then we have onChat function, which gets called when the messages arrive. We then call Amazon Translate to get those messages translated and display in the UI. As you can see, more than half of the code here is to wire up UI elements and getting and setting values for those elements, whereas the code to translate the messages are only few lines of code. In this case, I used Twitch chat as one of the source for real-time message translations using Amazon Translate. It can easily be applied to many other real-time streaming text scenarios like other chat platforms, customer service interactions, message boards, and more.
All right, so this is really a very powerful tool for adoption and retention. For everyone here, note that this code sample, the code from this example and many others are all in the Amazon Translate code samples page, so check it out. We've also published a blog post, if I'm not mistaken, about this specific implementation. All right. Now, as we mentioned before, Amazon Translate is also a very useful tool for translators. And next, I'd like to invite to the stage Eduardo D'Antonio, who is a director of globalization at VMware, and Ken Watson, the CTO of Lionbridge, to talk about how Lionbridge leveraged Amazon Translate to serve VMware more efficiently.
Great, thanks. Great presentation, by the way. Very interesting. For technology companies like VMware, we really need something like that. So here's a little bit about some of the VMware needs on localization and translation. If we get a sample of 20 million words, web content, field enablement, education, a combination of highly technical materials that goes to professional service systems engineers, that has cutting-edge, disruptive technology that sometimes is not even available in the market yet. So there's not a large population of not even human translators who understand it. It becomes highly complex to find the domain expertise, like you mentioned, that would be able to translate that, even though understand the technology itself. And then we also have a large combination of language. So that creates a very challenging human resource for us to deal with, scheduling, resource planning. At one given point, for example, we would need 300 or 400 linguists working for us full-time. And so what we normally do is we don't go and hire those translators directly. We engage with a strategic partner like Lionbridge, and we outsource the translation part to Lionbridge, and they manage that. And we've been doing this manually. We spend millions and millions of dollars every year with translation, so it's not our core business. If we would spend that money in R&D, for example, in development or improving products, would be a much better use of the dollars. But we need to, because over 60% revenue comes from overseas, so we do need content in different language to be able to sell and support our customers. And expanding on some of the points that I read, the quality needs to be very high. So it's a content that will go on the website, content that will go to customers, a lot of technical material on how to install the product, how to support the product, how to maintain the product. So the quality needs to be high. We need to scale the resource up and down very fast, so it's challenging because a product launch varies from time to time, so you don't need those resources constantly. We need to maintain consistency. It's very difficult when you have hundreds and hundreds of translators at the same time touching translation content, how we maintain terminology and the content being consistent also from one version to another. And then the cost keeps going up and up and up. And so one of the solutions that we found, and I'll turn it over to our strategic partner, Lionbridge, to continue with the presentation, I'll be back at the end, is the neural machine translation technology from Amazon.
Awesome. Thanks, Eduardo. Hi, I'm Ken Watson. I'm the Chief Technology Officer at Lionbridge. So we're the leader in this multi-billion-dollar translation and localization business. We create and translate and manage, as we heard from Eduardo, the global digital content and communication for many customers across the world. We have actually an enviable Rolodex of clients and many premium brands like VMware who really rely on us and have worked with us for many years. And they work with us through this crowd in the cloud scenario. So we have 100,000 plus professional translators in our community, and we bring them together and apply them to the needs of our customers. At Lionbridge, we're known for the scale and quality of the way that we deploy our translators. And I'm excited to share with you how we partner with Amazon and worked with our client, VMware, to deliver these translations. All right, so if you think about it, there are really several steps involved in delivering high-quality human translation. As we saw from Yoni's slide earlier on, there are many cases where machine translation is the perfect fit for purpose. However, if we want to target and ensure human translation quality, we're going to need a different step, and that would take the machine translation first, and we complement it with a human step we call post-editing. So this approach, machine translation plus post-editing, really kind of supercharges the translator, allows them to be much more efficient and much more effective in doing their job. So instead of having to start the translation from scratch, they will post-edit the MT output that comes from the MT engine and adapt it to make sure we've got the right tone and the right style for the target audience. So this is key. A good MT engine will take care of all the terminology and all the basic translation and getting the words across. And then what we need is but that part of it is actually fairly labor and thought intensive. And that's the bit the machine's really good at. Then what that allows us to do is reduce the scope of what the human translator's doing and have them focus just on the bits which convey the right tone and the right emotion into the message. So at Lionbridge, we really believe that all content should be made available in the target language for the target audience. And so in this kind of in this MT-enabled world where it's readily available, we really get to triage the content and make sure we're picking the right ones for MT and the right ones for post-editing. It's really quite exciting. If you can imagine a world where we can basically transform and translate everything that comes in the way of content, and really just based on the importance or the risk or the value of the content, pick the ones that will have a little bit of human interaction through this post-editing process. So our goal in this pilot with VMware was to put Amazon Translate through a real-life production process for translating high-quality marketing-related content. For the pilot, VMware selected 2 white papers, and we translated them into German and simplified Chinese. And the volumes that we had were good enough for us to really get a good assessment for the productivity gains that we could expect. I mean, what we were shooting for in the end result was that we should have no noticeable difference with regular translations, and we should meet the same high quality bar that VMware expects from us when we do regular translation. So of course we used the output we got from Amazon's neural machine translation engine to give our translators the head start. And at the end of the process, VMware measured the quality, and we measured the productivity through a process as compared to regular human translation. So for that measurement, we used a concept called edit distance. So edit distance really measures the amount of extra effort the post-editor needs to put into the machine translated words. All right, now, in terms of the results, I'll hand back to Eduardo to tell us how we did.
All right, thanks, Ken. Let's continue on what Ken was saying. We are tasked to run a pilot that would reproduce a real live translation project for us. And this is what we found out. First, we're very impressed with the results. We have a very rigorous quality control team in all the regions, and those are employees, and those are people from VMware, and some of them dedicated to just review translated content and make sure that it meets the translation quality. There's a lot of tools and systems and process to review the quality, and it's a pass and fail, usually for VMware to go to market is 99.3% in terms of errors. If you find more than 1 or 2 errors per 1,000 words, it's rejected and goes back for another human translator to edit and improve. So having a result like that from a machine translation using Nero is very impressive for a company like VMware to see how scalable we can be. For example, a product, we can spend $200,000 to $250,000 on a single project at VMware in the last 3-4 months using human translation. So the time to market and the savings could be really impactful for us. And so it was very fluent, the translation. Similar to what a human translator would be. If you just read it quick, you wouldn't find out that it was translated by a machine translation, which the statistical problem is. We quite easily identify this is done by a machine, not a human. In this case, it's matched the human translatable material pretty high. Almost no linguistic grammatical errors. That was another problem that it solves from the statistical. It was full of grammatical errors. Low rate of high severity errors. Sometimes better than human and better than other systems in the market, NMT, and 30% more efficient than human translations alone. Because with humans, if you think of it, it's translated, edit, proof. So there's 3 people touching it, and then a final review. So there's 4 humans touching it. And that shows the human, that graphic over there shows the human translation and the MT plus post editing. It reached a level that is very close. Even for a the other thing that is impressive about it is it's the early days of the neural machine technology in general, and it's already providing that level of output. So it will pretty much see in the near future that it will translate just like the same way as a human, and so it will be a big productivity enhancement for us working with Lionbridge to use Amazon Translate. Because then I hand off the content to Amazon, to Lionbridge. They use Amazon Translate, and the time to market for us is going to be much faster, and the cost is going to be much lower, and we're going to scale. So that all 3 things combined become very powerful and very impactful for technology companies. And there's not just technology companies, there are a lot of other companies that requires a lot of translation and translation quality and large volume. So that is why this is compelling and very interesting for us in the globalization industry.
Thanks, Eduardo.
To you. Thank you.
It's really by far the best part of our work to see what customers actually built with us. So this is super humbling and exciting. Let's talk quickly about some of the features that you have at your disposal right now. So you can translate between 12 language pairs, English to Arabic, simplified Chinese, French, German, Spanish, and Portuguese, and vice versa. The engines take plain text as input. They translate about a sentence in less than 500 milliseconds. That's the average service latency. And when the source language is not passed as part of your workflow, Amazon seamlessly gets the language ID from Amazon Comprehend behind the scenes. There's nothing that you need to do on your side. Getting started with Amazon Translate is almost embarrassingly easy. It's available through multiple SDKs, and as we saw in Kashif's demo, most implementations require 3 lines of code, like you see here. Your data is protected by AWS's security standards. I think that's almost needless to say. You can use SSL certificates to encrypt the data in transit, use IAM to control access to your resources, and rest assured that your data is securely stored at AWS. Quickly about pricing. So our standard pricing is $15 per 1 million characters. We also offer a 2 million character monthly free tier for the first 12 months. So you can translate a pretty big amount of content without paying a dime for this. To take you back to that news article that cost $150 to translate with professional localization, in this case, it costs you 7.5 cents. Now, a little about what you can expect from us going forward. First, we're investing heavily into getting a lot more training data, and we're experimenting with new approaches for architecture every month, so you can really expect the translation quality to keep improving. We're also working on launching many more additional languages. In the next few months, you'll see Japanese support, traditional Chinese, Italian, Russian, Turkish, and Czech. And there's really a bunch more specific features that I can share with customers that are coming up under NDA. You can get started at aws.amazon.translate/translate. And shoot me a note if you have any questions. I'd really like to hear from you. Ken, Eduardo, and I are also going to stick around after the presentation if you have any immediate questions.